maybe a couple of words to explain who I am. My name is Polizois Kokkonis. I work for Nokia as a product manager. I'm working mostly for, I work long for products, and I'm especially interested in working for the environment of products. That means for the ecosystem that goes around products. Things that have to do with the API economy, how you use the products as a platform and have products developing around that and so on. And also I'm looking very much into serviceability topics. What I would like to talk about today is about how we use models in software development processes, and my interest is large scale. So to put it roughly on large scale, I'm currently working on a product, and we're talking about something which is developed by a team of roughly 200 engineers distributed over 4 different locations, working even in different time zones. So that is the type of scale that we're discussing. And that is where I think that models are coming essential, and I want to talk a little bit about how this is working. So let's start a little bit of Let's start first with a bit of history. When I started working when I started working,
it doesn't switch on from there, and I'm not sure how that's done. And I think we can hear you. Yeah, okay.
When I started working in software, I came actually from a research background. I was working in labs, and I was quite familiar working with assembly on old Intel processors, also on Motorola's and so on. At that time, telecommunication was developing products on line cards. So they were not computers, they were line cards with processors and memory and so on, with own operating system. These were deployed, and that is where the software was running. Now, I looked at the assembly code when I started working, and I said, it looks strange. Why do they write the code like that? Why? It's unfamiliar. They had strange structures. What did I find out? That they were actually using a tool which was, they were making sketches of a call flow. So the classical telecommunication software is like, there are messages exchanged between different entities and they are doing something. So they were making a call flow of that, and based on the call flow, the code was roughly automatic generated in assembly, so low-level language. And then it was deployed on the systems and running and testing and so on. And what was quite important, they had a process which was called phased, I need to read that, I don't remember the name. It was the PPP process, which was the phased program planning process, and it originally came from NASA. And that was based on such an approach. So you had a system engineering, then there was an analysis, then design, then the code and so on. And it was roughly based on such a relay principle. So somebody was creating something and giving it to the next one. Somebody was creating the model and giving it to somebody who would then do the code on the model and so on and so forth. The next step that started developing, and we are now at the beginning of our century, actually, there was this design patterns. Telecommunication started going to what I would call commercial hardware. So we were writing code that would be running on Unix servers. It was not very much application, so you did not have user interface and so on. It was large servers doing the code and doing the routing of the things. And still we had other pieces that were running on line cards or special purpose processors and so on, but this started coming in, and we started looking at IT, how are they doing things? So one thing that came up was object-oriented architectures. Things were different. And design patterns was something which was quite important, because what these guys did, it was this famous Gang of Four book. I don't know if it is something that is used today, but at that time it was quite nice, because it introduced 2 things. First, they said there are several things that we always do the same time, in the same manner. So we are creating that, we are coding like that, and they are best practices, and best practices should be shared so that everyone uses these best practices. Plus, one other point which I will come to next is that it is an easy way to communicate. At that point in time, if you were saying, we will create a proxy to do this, somebody would look and say, what is a proxy? We have a model, and this will be now a singleton, and we will create a factory that creates the object. These things came familiar with such a work. At roughly the same time, this unified modeling language, UML, came out, which formalized how you create models for software. It introduced also other things, so not just the class models for object-oriented design, but it introduced sequence models, deployment models, and so on. So you could formalize these things, and it was very nice. So we started working extensively with that. It was, at that time, it was Rational. It was a software company that was later bought by IBM. And they had software suites that would fit that and also provide a software engineering environment. So you would be creating the model, and roughly you could also, from the model, you could automatically create the code. Now, the problem that we were facing in such a situation was, okay, you create the code, you go to the testing, and at some point in time you also have the software deployed. And to clarify this a little bit, we are talking about software which is deployed in telecommunication operator networks. That means you have availability requirements of 5 nines. The systems are not supposed to fail. When these systems fail, then you have lack of telecommunication in the whole country. So the requirements are very high. From time to time, we do have to correct the software. So what do? Do you go back to your model, change the model? Do you do the fixes in the code? Then how does your model fit the code? So you have a little of a problem there when you're working with models like that. And what was quite important working with this design, we did not really have the speed to create new things. So the demand came that things had to be faster. IT world was moving faster. If we look at it, and that's a more recent example, somebody would be saying, when Google deploys a service, they need a couple of minutes. When a telecom organization deploys a new service, they need a few months. We needed to be faster. So about end of previous decade, there was a new approach, and it was Scrum, Agile software development, iterations, and it develops further to what is today called DevOps. So what does this mean? Instead of this relay thing that somebody creates something and gives it to the next one, the approach now is rugby. Everyone together, passing the ball between one another. Teamwork. Now, this was roughly based, the ideas for that came from the Toyota production approach in the 60s and so on, lean thinking, influences systems thinking from Edward Deming, the learning organization, Peter Senge, Chris Argyris, and so on. There was a lot of thinking behind that. But roughly this Agile came, and I will read it to you to be exact. It was quite simple. There was this Agile manifesto, and they said, we are uncovering better ways of developing software by doing it and helping others do it. Through this work, we have come to value individuals and interactions over processes and tools. Working software over comprehensive documentation. Customer collaboration over contract negotiation. Responding to change over following a plan. And if you put it in a very small nutshell, it says that if you are trying to create software, you are not doing what is exactly repeated manufacturing. You are not doing the same thing every time. You are doing something new. And this has an inherent uncertainty. Now, if you embrace this uncertainty, then there are two ways to do it. One approach is to sit back and think very carefully what are all the possible options, and then decide, okay, I'm doing this. You still have the uncertainty. The other variant is make small steps. In every step, you check where you are. And you probe your way with it. And that is the approach of Agile, of iterations, of Scrum. They say for every larger iteration, you have smaller iterations. The team is creating code every day, and they are testing the code that they are creating every day. And this is the flow that should be. And if you go to the DevOps approach, it says that you even deploy the code very frequently and get feedback and correct it. That doesn't mean, with the very nice things that Christos just said, of course you need to test it, you need to document, you need to do everything like that. But the approach is different in the sense of the fast and short iterations and the mode of cooperation. If you look at this Agile approach, it has also implications in how the organization works. It redefines the roles of people in the organization, and this is something which is largely followed. Now, the tricky part with Agile is when it appeared, the model was made, they said, okay, we have a Scrum team which is working together, and there are 5 to 7 people working in the Scrum team. As I said before, for the product that I'm currently working for, you have a team of about 200 engineers. So how do you do that? There has been a lot of work and discussions and so on. How do you scale this Agile approach? There are a couple of interesting approaches like SAFe or less, but I will not go into this detail. What we're interested here, because our focus is models and code. The models in Agile, there was, in the early days, it was something like, no models, we're Agile, we don't do UML. We just write the code as it is and we test it and we work like that. That is actually not correct. That is not even what Agile evangelists are saying. But the idea is use the models wisely. You need the models to communicate. It's much faster if you describe things based on a model so that your colleagues can understand you, the Scrum team, and you can also communicate it to the other Scrum team. You can also communicate to other people. And as I said before, in a large-scale product, you have people working in different time zones. It's not possible to work together. If you have teams cooperating on the same product, some are working in the US, some are working in Europe, and some are working in India. They hardly have the same working time. So when the guys in India are working, the US guys are asleep. So you need ways of communicating efficiently, and the models are extremely important for that. What you don't do, or what you cannot support really, is to recreate the model in every iteration. But that's maybe not important. So you think in models, you communicate in models, you discuss in models, yes. But you do not idolize the models and use them as, how should I say, as a holy cow. So the models are there, you create them, you have the code is running, you test it, and you're done with. And then you recreate the model. You scratch the model every time. You remember what you did. So instead of using this formal UML approach where you have this in rational rows and you keep your long models and so on, what was the approach in Agile teams? They sketch the models and you make a picture out of it. And if you want, later you can look at the picture and say, oh, that's how we did that. Okay, now we need to revise it. Do it. So, in a sense, Agile is also looking at the product architectures in a little bit different manner. So instead of, I think Craig Lama, one of the Agile evangelists, put it quite nicely. He said, on one side you have the architecture of buildings. So people are designing a home, then they are building it with bricks and so on, and that's an architecture. But we're also talking about garden architecture. And in garden architecture, you put the plants where you want, but then the plants are growing. And you adapt to how they are growing. So you do not look at something which is rigid in terms of architecture and the model, but as something which is evolving, not just because of what you are doing, but in a more complex way. And this complexity you need to address. But still, the importance of models is not to be underestimated. Now, I would like now to come to the third part, which is something which is happening now. And it is the impact of artificial intelligence, machine learning, deep learning, reinforcement learning, and so on in whatever we're doing. And I think this is something which is having a huge impact on modeling, because it changes the way that we understand models. So, artificial intelligence. It's a huge hype. That was a very nice sketch I found. So, a nice looking girl is on an island, she writes help, the planes are going by, they don't care. Then she changes, writes, I know machine learning. And they're coming to her rescue. It's a huge hype. You have courses about machine learning. Machine learning is in everything. If I go to a session about evaluating or discussing with several startups about their ideas and so on, there was not one of them that was creating software that did not say, and our system supports machine learning, and we will get the data and do this and this and this. Not one. So I think it's about 99% of the companies are saying that they're doing artificial intelligence and machine learning. So why is that? Because on one side it's easy. Nowadays it's easy. If you go to do machine learning, everything is there for you. You can get TensorFlow, Keras, you can just program it. You need to spend some time to understand what they're doing, but you can do it. Data are everywhere. So you want to do face recognition? Yes, there are already databases of data. You can train your algorithms and so on. So it's easy. It's everywhere, right? But we have to start thinking. So the background here is not by chance like that. Do you know the game of Go? Yeah. Who knew the name of Go a little while ago? Almost nobody. But it was a huge hype when, I think it's a Google subsidiary that they said, we now have an artificial intelligence algorithm who is able to beat the best player in Go. And it's a more complex game than chess. So they're adding in complexity. And that made the news. And what is it actually contrasting? And that is why I have on the left side Lady Lovelace and Alan Turing. Because actually Alan Turing wrote that, but he referred to Lady Lovelace. The idea is that can we have something which creates something which is original using artificial intelligence? Is it something which is possible? Because the idea there was that you can program things, and you can program actually things which, okay, they can do something faster, but they cannot do something new. And that is the point where artificial intelligence is coming now to a verge, and machine learning is bringing that in, because it is creating something which might be different, and this will influence the way we model. So first I would like to have a look at what might be considered a paradigm shift in what we normally do. So what do we normally do with software? We have the data and the business logic. A classical approach for a computer program would be you have some data, you have a business logic, and with these two things you perform some calculation and you get out the results. I think this covers most of the cases for what we do with software. Now, let's look at the other side. What a machine learning, deep learning algorithm is doing. It's getting the data and the results, and it calculates the business logic. That is what it is practically doing. You have the business logic formulated in a highly parameterized manner, and what you're doing is I'm going to change these parameters of the business logic, which is quite complex. Maybe I do not even understand what exactly comes out, and change this until the data create the results that I'm talking about. Then I have trained my machine language, my machine learning program, and I have the business logic that I need. And that is having a huge impact on what we understand under models. Because up to now, models were what we understand in business logic, and that meant we put our thinking and say that is how we model that. And if you go to machine learning and deep learning, you say that I create the model. Maybe I do not even understand it. There's a lot of work done in machine learning and deep learning that has to do with how exactly do we interpret what the model looks like after we have trained the model. So we do this process, then we have created practically the machine learning model, and we're trying to understand, okay, now what is it exactly recognizing? Let's take, we take a face recognition algorithm. We do the training and we come out and we have the algorithm. Then after that, we start saying, okay, this layer that we've introduced there is taking broad characteristics. Then the next layer is coming more to understand whether this is a face or not and so on. But this is afterwards. We did not program it like that. It happened to be like that. And as a conclusion, I would like to come to the 2 points which have to do, because our session today is about software for domain experts. So what is the role of domain experts here? And I would say that we first need to understand 2 things. I don't know whether it is familiar, it is an Akira Kurosawa movie called Rashomon, and it introduces what is sometimes called the Rashomon effect. The idea of the Rashomon effect is actually that you have multiple good models. Translated in our case, in Rashomon it was not about models, it was about different people interpreting the same situation. But in machine learning, you do not have one model. You have several models and they are good. You do not assess the models in terms of whether the model is correct or not. You assess them in terms of, is it predicting accurately or not? So you have a predicting accuracy only. And that is why I put here Rashomon. This is the Rashomon effect, that you need to accept the fact that you are not modeling, you are creating different models, and you need to assess whether the models are good or not, based on facts. And you need to accept the fact there are several good models. And Occam's razor is coming in the favor of simplicity. So what is better? Is it better that I have a model which has a better accuracy in prediction, so goes to 98% prediction accuracy, but I cannot understand why this model works? Or do I go for a model which goes with 95% accuracy, but I do understand what it does? And these are things which are quite interesting and important, because if you're looking at approaches which are coming from data science field, they are trying to find out which of the variables, which of the things that I'm doing is creating the most part of the result, so that I can look at it. On the other side, if you're looking at such algorithms, and you take, for example, what was recently again in the news, that they could, companies could prepare software which, based on machine learning algorithms, could have better accuracy in detecting tumors in computer tomographies than expert. So where do you start? And that is the game where domain experts should play. So what part of the model do I understand? Where do I play between simplicity and accuracy? The more parameters I let in, I can improve the accuracy, but I lose in simplicity and in understanding. And that is Occam's razor. It's an old idea. Maybe I'm not so sure if I'm misusing his original idea here, but I think this is something which fits what domain experts should be doing in our case. And with that, I would like to thank you and welcome any questions or discussion points that you would have on that. Thank you very much.
You didn't want to specify more in detail about how agile the scale, so I know that Nokia or all the company has switched, were forced to switch with the software defined network and virtual virtualization to this normal coding, IT, from the specialized world to the IT world. So probably they were forced as well to switch also how the requirement are arriving to the end of the code. So now I ask you how these agile work with so strict requirement that you have in the telecommunication industry, where, as you say, resilience is very important, security is very important, because now we use the mobile phone to authenticate everything. So how you integrate this high requirement in this agile framework?
I would say that this is not the problem for Agile. This is not the problem for Agile. What Agile is actually doing is, in such cases, Agile gives you better visibility and predictability in what you're doing. So previously you were developing something, and at the end you found out, oops, I did something wrong. Now you are testing and checking all the time. The requirements about high reliability and strict requirements on availability and so on, these are inherent in how you build the software. If you know it, then you bring it in. So I personally, I don't think that this is any problem with Agile. What is sometimes perceived as an Agile problem is that this transparency translates to some, how should I say, to some better visibility of risk on product management and sales side. So previously you had a large plan and you said, I will create a product in 9 months from now. The telecoms are quite slow. They are traditional companies. When they say we want to buy something, they issue an RFI, RFQ, and they purchase in 6 months. They start checking that in 1 year, and they deploy in a year and a half. So that means that for the company which is creating the software, they have to be able to offer something well in advance. Now, when you have this waterfall model, you have a plan for the next one year and a half. Then the product manager says, okay, it will be ready then, I can sell, that is the data I'm selling. And these are the features. When you have these iterative cycles, then the planning is shorter, more firm, but shorter. So if you want to make deals, then you need to have a better understanding of the risk.
But there is another.
But in terms of reliability and so on, I would say that this agile approach is not.
But the requirement phase, I think, is compressed. So not all the requirement. I don't know. Is not all the requirements are put in place, or maybe they are not checked all the time, or this was wondering.
It does not change. You can start with the requirements that you know, and if requirements are coming, then you can check them afterwards. If you know them in advance, you should check them all in advance.
And then also about the scale, how you say you work in Agile is supposed to have 6-7 people, small number, and how you scale up?
There are some approaches for that. So Nokia has been working in this mode for quite some time. And the approaches that have developed on that, which are now also advertised, is this safe scaled agile framework, and the LESS, which is large scale agile or something like that, large scale Scrum, sorry. And they are focusing exactly on that. They think, okay, how do you scale that? I mean, agile is very much based on the interaction of people. Now, when you have many people in different locations, how do you manage that? And there are several techniques and ideas how to do that. So, for example, this scaled agile framework is saying that you have large planning sessions that go over that. There are other ideas in less and so on. So it's a bit tricky how you do it. And to a certain extent, you can also manage things by splitting what you're doing in well-defined components. And in my perception, this is something which is done. So Jeff Bezos in Amazon was quite famous some time ago in the software world, because he said, every service that you make should be exposed through a well-defined API. Whoever doesn't do that is fired. That was a joke, but the idea was you should make components which are well-defined and have well-defined interface. And this component-based software is something you can admire that. For example, take Linux. It's an open source product, right? It has a large scale of complexity and a very large number of engineers who are working on that and doing things. How does it work? How do they communicate? How do they arrange what they're doing? Because every component, there are components which are doing things and then they fit together. They have well-defined interfaces. Every component explains exactly what it is doing. And that has a lot to do with modeling. Because the best way to communicate what exactly the component is doing is via modeling.
And also because there's so many components, so many relationships, it's an enormous undertaking to map all the relationships. You mentioned in the beginning that you were working on a system earlier on when you weren't using conventional software, and that during that time that there was a program that was tracing the code. The code was actually the communications of the code, or what part of the code was actually in some sort of model?
The code that was creating a particular service. So this was done based on a call flow. You say this message is coming in telecommunication. In traditional telecommunication, you have messages that are coming. If you go with number 7 signal, then you have a signal that is coming which says user A wants to call user B, for example, and then the software needs to do something in order to find out where is user B. Does user A have is user A allowed to make a call and so on? Should we, I don't know, put call waiting activation? All these are checks in the code, and you were depicting that in sort of a picture.
So it was like a mimic diagram.
Exactly. And then code was created automatically behind that.
Why was that concept dropped? It sounds like a very good concept.
The concept was quite okay and it was working, but the code created was assembly and it was slow. When we started working with more advanced models and object-oriented language and so on, the models became much more sophisticated. So if you look at what UML is providing, it is, I don't remember how this language was called, but it's not comparable. It provides a lot more capabilities and complexity. But the problem is what you test and where you find the errors is the code, not the model.
Produced code, whereas yours produced code and also showed you traceability.
The traceability of the code you have through various tools in what you're doing in the code. So you also had, Rational did a lot of work on that also to build up the traceability of the requirements. So in principle the idea was that you should be able to say, I have requirement A in my requirement documents, and then this is linked to a particular feature, and the feature is linked to a particular test case with a particular part and changed in the code for a checking, so it was working together with a code version system. You had code version for the test cases, code versioning for the software that you were creating, so you have the whole chain. But this is working also now.
Yes, so that's a documentary method. It's not you're not actually modeling the code like you were in the first one the way you described.
With UML, the approach was also that you can create code from the UML diagrams.
Yes, but it's
so you have the classes and subclasses and so on, and it was creating the code.
Very basic. What you can produce from.
To a certain extent, it was possible to do it also in a more advanced form, and there was also active work to do this, but it wasn't, how should I say, it wasn't so much used that it was pursued further.
That's what I'm going to talk about.
So at a point in time we tried that out, okay, for a basic code skeleton it was okay, it was creating things, but then when we started writing and creating and so on, it was too slow to go back and create everything in the model and recreate the code. We couldn't keep, actually the tricky part was you couldn't keep them in sync. Because you were correcting the code, And actually,
corresponding to
yeah.
that.
And then we said, okay, UML is great, but to build a model and start working, and then if you need to recreate the model and do it, it's faster than relying on having the model actualized every time that you change something.
Any more questions?
Yeah.
One small general question regarding Nokia, how they do things on development. First of all, thanks for the interesting presentation. Do you consider using UML diagrams or documentation or design patterns when developing a software?
Yes.
Because I talk with different people from different companies, and a lot of them they don't really use it. Especially documentation, a lot of them they're like, no, we don't write, we put the documents itself, so it really depends.
No, everything is approach and document. So there's quite a rigid approach in that. It is used. I just said that you do not, you use the model, but the model is not something that you definitely need to have. If you say, if the developers say that we don't need to put a model together to do that, then probably they don't. So the idea, and that is a central part of this agile approach, is if the developers think that they don't need this, then they shouldn't do it. They shouldn't do something that they don't need. But when you're talking about documenting, they need to be able to hand over their responsibilities to somebody else. So somebody needs to be able to maintain the code. That is something that the developers need to do. They have to do this. If they don't document the code, if they don't write the comments and they don't know what it is about, then when something goes wrong, how do they correct it? Exactly. That's why I say if they don't need this, but they should be able to understand their needs properly. So everything that Christos said before about, how should I say, about decent practices, this is valid.
I totally agree. Just because we are teaching to students these things, and they go to some companies, maybe small companies, but they don't see these things, and they are like quite new levels in university. So I'm just asking for Nokia how they consider things. So yes.
I think the problem is that some maybe smaller companies, on one side, okay, the requirements may be not so strict. So you're creating something, but it's not something where there is a huge risk if it doesn't work properly. So telecommunication software is a little bit different in that manner. Also, testing procedures and quality assurance are more rigid. On the other side, they might be more hasty to do something, and in our case, what you practically know is if I do not spend now the time to do it properly, then later on I will have under pressure to spend 10 times as much. So errors that you correct early on, they cost much less. Because if you have the errors in the field, then it's not just an error, it's not that you don't get the money, you pay penalties. If the systems crash, then there are huge penalties which are involved. So that is too risky. I cannot say that it doesn't happen, but we have to do everything to prevent that. Yes.
Yes, so we spent back in 1999, I remember, some of you were probably still in primary school, nursery. Somebody gave me, when I first started moving, realizing I'm not going to be a superintendent, I'm going to software. Somebody told me, you know shipping. I knew nothing about shipping. So you have to write requirements about the shipping ERP system. They gave me a book with rational rows and the other book with UML. Brilliant. I thought the rational rows was great. So it was so easy to just write down what you knew. The problem was that most of the money we have spent is in software that we didn't develop because of things we didn't know. And a lot of these modeling methods, when it comes to software which is like telecommunications, where you know exactly the domain, it's very easy to use them to develop what you're trying to develop because you're talking about machines and you know exactly how they interact. When it comes to people and a very ad hoc purchasing process in shipping, there are, I would guess, 80% of the things you don't know, and only 20% of the things you know. So these types of modeling techniques, if the domain where you are doing the modeling is very ad hoc, sometimes they don't allow you to see what are the things you don't know because there's no converging goals. It's just documenting processes, and it's very difficult to interact between the different functions of the company and to sort that. So for example, when it comes to a purchasing process in a factory, you just come up with a just-in-time mechanism and you know how to do that. When it comes to a purchasing process on a ship, you are actually purchasing to repair things. You are not purchasing to manufacture things. And it's very ad hoc. And that's where we found that the current rational rows and UML techniques we use, that's where we found we had so many gaps, whereby we never thought of a little thing that effectively forced us to redesign the whole thing 2 years down the road. And it happened on several occasions. And now we've come up with a more holistic approach to how to model complex processes. Especially with things like ERP systems and stuff like that, where users are involved and the processes are not well defined, it is much more difficult to do that with traditional modeling methods.
I totally agree with that, and as I said, I think these models, they help very much when you start to create something, and also when you want to communicate something. So the model is, for example, it provides you a possibility to describe the use case. Theoretically, if you want to base everything on the model, what would it mean? It would mean that you need to create the model for every use case.
Or have a methodology that it allows you and shows you what are the bits you haven't covered in use case.
Yes, but the model do not reach that level. Or at least in our case. So what we were doing with these models was to say, okay, you have in your network this entity, this entity, this entity, and that is a typical flow. But this flow cannot cover everything that happens. So if you go and try to model every flow exactly like that, you lose a lot of time. As I said, we use the model. For example, if you want to explain to the customer, or if you go to the standardization and you want to explain how does this flow work, then you make a flow based on models, right? Even the standards, they design a flow, but they do not show every flow. So you have a lot more behind that, and I think this is also your case. So you roughly sketch what is my purchasing process. It looks like that, but you cannot model everything with rational rows. Not because it's not possible in the modeling language, but because it would take you too much time. I mean, if practically seen with the model, nobody works. So the model doesn't do anything. And most importantly, from my perspective, you cannot even test the model. You test the code.
Yes, we have developed a new type of modeling methodology that gives you a much clearer view of what are the processes you have encountered. And because the model is actually the code itself, you can also test the model through the code. And there's traceability of how you got to the results you got and which node in the model was not working.
That might very well be the case, because UML was meant to be a universal modeling language. So it was meant to cover a very wide range. But there were modeling languages, for example, what you asked before about telecommunications, it was a telecommunication specific modeling language. You couldn't model anything else with that. It was specific for telecommunication things. It was like, do the call, do this check, do this. It wasn't generic. You couldn't describe a business process. So there are different types of modeling languages, like special purpose or domain specific, I would rather say, and generic like UML. Okay?
You said that using your development and design methodology, and that was how long are your iterations?
The rule is that you have 2 weeks cycle. So the sprint cycle in the Scrum teams is 2 weeks.
And then you deploy it or just have for the testing environment is weeks? Is a full deployment every 2 weeks? Or?
Every 2 weeks you have a complete cycle. So according to the process, every 2 weeks you have a new release which is doing something better than the one before. You do not deploy on the customer premises.
So for testing purposes,
For testing purposes, it should be adequate. So you should be able to test that. What changes in that is the idea of the DevOps, where you have your quality assurance and development process, and you deploy also what would probably be production environment in telecom would be the environment that is working, the one that you're using to make phone calls. But that is currently not the case. But that is something which is discussed. That you have an integrated DevOps cycle, that you combine development process with the operative processes to deploy the software. But that would mean practically that you have quality assurance and testing in different stages. That the customer is also testing and deploying. So they are checking into particular use cases that are relevant for them, and once they are certain that it works, then they deploy. But that is DevOps. That is something which is, I would say, rather new. It was presented in the last Mobile World Congress as a new idea, and it's not something which is right now happening. It is in discussion.
Thank you very much.